Very pleased to come and present the present and future of training in AI. So maybe I'm biased a bit because I run a training program in France, so everything I say is maybe focused on the French context, so please apologize for this. So yes, the reason why I'm here today is that we are operating a master program, which is one of the leading programs in Europe, maybe worldwide, created in a bit more than 20 years ago, called the MVA Master Program, with almost 200 students graduated in 2018 and certainly more than 200 in 2019. We are offering about 40 courses by really reading excellent researchers with international reputation, intensively active in topics such as machine learning, computer vision, natural language processing, graph-based learning, etc. And there are about 10 institutional partners, so most of the major institutions from higher education in the Paris region and two very big universities are associated. What we teach there at a quite advanced level is what any AI student should know, right? So it's of course about machine learning, which is a combination of some statistics, computer science, so linear algebra, optimization, algorithmics and coding, and also some expertise on structured data. And at least one of the main examples, such as time series, images, video, text and strings, graphs, functional data, and many others. So the audience for this program comes from, let's say, basic education in math, electrical engineering, and computer science and statistics. And the goal is to train the experts that will design the AI technologies for the, let's say, close future. But maybe we need to think what the society and companies will need in the near future, and maybe a little bit beyond than the nearest future. We know very well what some major internet companies expect today in terms of skill. Of course, you should master deep learning algorithms, programming environments such as TensorFlow, and having also the capacity to deploy on high-performance computing infrastructures. What historical players in industry or healthcare think they need is the same, but maybe we should question that. So I will come back to this point in the end. So in the near future, in order to build these AI technologies, first we need to take into account that the academia begins to lack of some basic elements to do the job of disseminating knowledge and developing also knowledge. So first of all, many influential researchers are recruited by private companies. I'm not sure we have not yet passed the, let's say, the equilibrium, and that maybe this will become a problem in the next 2-3 years. We need also to attract more female researchers in our communities. That is one of the major purposes in France, to develop programs that will bring more diversity in terms of gender, races, and another limitation we are facing now is the fact that we don't have engineering capacity, tools, and even the data are missing in order to develop knowledge in the context of higher education institutions. I think these are three important issues, and I think it's a question how to address these problems for the community. At the same time, beyond, let's say, training the people who will design AI technologies, there are some other things that society expects from us. So first is maybe to make AI concepts more accessible to not only to very expert students, very highly skilled and highly educated, but also to college students, and also to train all the workforce that is already there in companies and in administrations, and that could maybe improve their skills. Also, medical doctors are asking for, having access to this kind of content. And I think one of the major stakes is also to make these concepts more accessible to people that are in non-engineering training programs, including law, medicine, social sciences, humanities. etc. The other important goal is to make this technology more familiar to other citizens, school kids, decision makers in particular, entrepreneurs, investors, and regulators. So what we will do in 2019 is already to cover part of these needs. So we will launch with the contribution of Francis AI an online course that will be in French in machine learning for undergraduate students and also professionals that want to get some program teaching the fundamentals, principles for developing machine learning applications. Another thing we'll do is to have some kind of intensive classes for trainees in medicine. So we call this the MVA master classes. And also we will develop a full program, full master program, including a PhD track. For the main target will be students who will not come from computer science or mathematics or electrical engineering. So there will be students in engineering sciences, in social sciences, in biology that will benefit of this program. Now let's think about maybe the farther future, because all this is pretty easy to develop and we see the impact we will see the impact pretty soon. But maybe we think to need a bit more that what may happen maybe in 5 or 10 years. Because these are the people who will be, you know, in the job market, the people we are training today that will be in the job market at that time. So I have, well, just stating some ideas that are my vision of things. So of course you can argue if they will come true. But I think, and this is already the case, that the algorithms are being commoditized. So maybe today the purpose is not to develop, you know, new algorithms. And maybe also coding will be commoditized. So everybody looks today for data scientists and coders in companies, but I believe that this kind of profile maybe will not find the same importance in the next 5 to 10 years. Another thing that will happen is that I think there will be a lot of disappointment in, let's say, out of the internet sphere, in the industry and healthcare, around the applications of AI. And maybe for good reasons, but also for bad reasons, because maybe people will not take the good paths to achieve what they want to achieve. I think, having said that, that for sure, some categories that are highly skilled and have a lot of expertise and have followed long training programs such as engineer, medical doctors, and lawyers for sure will be disrupted. I think that's a certainty. So the question is how we will maintain some expertise to act in extreme situations. And I think this is not an easy question. And the other comment is that for sure the men and women will stay in the loop. I refer to a statement done by Kasparov, which I like, that basically says that if you add some human in the process and you have a good process, you will always beat the machine. So what should be the future of AI, and then how should we orient the teaching programs for training the future generations? I will just give some examples of directions. I'm not sure I know how to develop that, at least in France, because we need to start very early. I'm not saying that there is no activity on these topics, but I think we really should think about the training programs, taking into account these major objectives, I think, for society. So first is to help sciences beyond computer science to use AI to improve their capacity to explore the phenomenon they are studying. Okay, so that's, I think, a first goal. Another one is that keeping in mind that in the end there is always some human operator that will use the AI technology. We need to think how much biologically we can absorb the interfaces that are presented, and I think that's an issue, especially for complex man-machine interfaces. And you can think about airplane pilots, but you can also think about drivers that will have more and more automation in their car, and dealing with the transitions is really a major source of accidents. So basically it's about the human factor, and this requires to have more knowledge about, let's say, the physiological capacities of the human body. Another one is maybe to save the planet from deep learning, because it's highly energy consuming. Some researchers say that, okay, it's nice to have access to important computing capacity, but sometimes when you have constraints, maybe you are more creative, and maybe you can save some computing power and have similar realizations. So that was the case actually in one of the basic achievements for handwritten, one of the first achievements where machines reached human performance. In handwritten character recognition, the first algorithm was a very complex neural network developed at the end of the 80s by Yann Lequin. And 5 years later, another algorithm, extremely simple, only 2 parameters to calibrate, reached about the same performance. And I will end maybe just mentioning the use for the industry, how they should take into account for applications in the industry. I'm talking about the traditional industry such as energy and manufacturing. So there are 3 sources of knowledge there. There are some traditional sources such as field expertise and simulation that is based on physical models. And now people expect a lot from machine learning, that is data-driven expertise. And it is not clear how to combine the 3. So that's also, I think, one direction that we should develop in training, is that people stay informed about the really fundamentals of the phenomena they are studying, because I see a tendency to bet too much on the data, too much on the algorithm, forgetting what is behind. And so I think that when you have physics behind a phenomenon, of course this should condition the way the design of the machine learning algorithm should be considered. Thank you very much.
Thank you very much, Nicolas. Thank you.
Thank you.